So number 3 question is a lottery buyer purchase 10 tickets a week. So 10 tickets a week. Always playing the same 10 5-digit lucky number. So we're going to write a program that initializes an array with the following the 10 lucky numbers. And let the player enter this week's winning 5-digit number. The program perform a binary search through the list of the player's number and report whether or not one of the tickets is a winner of this week. We have only 10 numbers. So basically, you can actually do linear search. But we want to show you the binary search is faster. So it will make this lottery buyer happier. Okay? So before we start this program, let's actually review one more time what's binary search. It's okay? Let's review one more time what's binary search. So let's take a look at the searching algorithm. It's okay? Searching algorithm. We already did the linear search. We want to do the binary search right now. Let's take a look at the algorithm first. It's okay? Algorithm first. Then let's take the picture. So you need to do this. First, you need to set your first to 0. Your last is the last. Alright? Once you do that, then again your found has to be false. So first is first, the last is last. Found is false. Position is -1. So when your found is still not true, and the first is less than equal to the middle. Okay, so if first is less than to equal middle, your number will be land on the first part. Okay. All right. So as soon as you do that, if you find a number, in case you find a number found equal to true, all right, then position is the middle. That's when you find it right away. If not, let's take a look. If your number is greater than desired value, so we are going to search 23. So 23 is actually greater than 16. So what we're going to do is we're going to search, all right, so we're going to search this part. So we have to move our first to this guy, your first. So move your first. It's okay, move your first. All right. Now, if your number is less than, so for example, if you doing, this is the thing, if you look for 8, first you go to middle. If you look for the 8, so the A is smaller than the middle one. So once you are there, you adjust your last. Your last will be middle plus 1. Your last will be your last will middle minus 1. So that's your last. Alright. So one more time here. So this is a number right here. If I search for 38, alright, so let me double check right now. I'm looking for 38. Is that right? I'm looking for 38. The binary search, I go to middle first. So I come here, the middle here. So 38 is greater than 16. Is that okay? 38 is greater than 16. So my last state don't need to change. But my first is middle plus 1. Alright? Do you understand? Do you understand? So let's take a look here. Right here. Middle plus 1. So if I search for 8, now I search for 8 right now. If I search for 8, now I'm going to search for 8. So 8 compared with the middle is 16. So 8 is still smaller. 8 is still smaller. So we are going to drop this part. What we need to do is we need to fix our last. You understand? So at this time, your last is middle minus 1. Middle minus 1. Alright? So that's how we fix. Alright, so let me ask you a question right now. When you search it, alright, when you search these, if the number you search is greater than middle, you are going to adjust your first or adjust your last. Let me know. If the number you search is larger than the middle, alright, so you already know you're going to the larger side. So at this time, there are two variables. One is called first, one is called last. You adjust the first. The first will become what? How do you adjust it? How do you adjust the first? Middle plus 1. Okay? Middle plus 1. Now, if you search a number, if the number you search, if the number is smaller than the middle, alright? If your number is smaller than the middle, which one you need to adjust? So you have two variables. You want to adjust your first, or you want to, yes, you adjust your last. Alright? So middle already there. So how do you, no, adjust your last. Now you adjust your last. How do you adjust your last? Already have a middle right now. So middle to the one to the left. How do you do that? How do you adjust your first? How do you adjust your last? It's middle minus 1. So take a look at the code right here. First, your first should be 0. Your last is size minus 1. You're going to have a middle point, but right now we don't have it. Later we divide by 2. Your position is -1. Found equal false. By the way, you need to memorize this. While not found, your first still less than last. Okay. First calculate your middle point because this integer, so it will be truncated. You understand? 4.5 will be 4. Now, in the middle, this is a lucky shot. If the number is right away in the middle, we found it. That chance is very, very small. Most of the chance will be this. If the value is in the lower half, we adjust the last. Last is middle minus 1. If the value is the upper half, we adjust the first. First will be middle plus 1. Then you return this position, then you come back to do this. Do you understand? Yes or no? Alright? So let's get back to our question right now. Everybody. So let's do our classwork right here. I need you to download this one. Is that okay? Pro Challenge 9.01. Oh, sorry, wrong one. 9.02. Can you download that one? Okay. So we are going to do the binary search. So first, let me please download it right now. Okay. I'm just going to do this classwork, same thing. Is that okay? All right. So I'm going to delete this one. Okay. Remove it. And I'm going to take the second one right there. Is that okay? 402, right? Okay. All right here. Okay. So you just learn the algorithm, okay? But you need to apply to what you need to do right now. So first of all, it is better to make this array to be a const. It's long because these numbers are long. Okay. Now we are going to do this. The size is 10 here. Okay. So we are going to do this. Okay. Search this. Search from your ticket, from your array. And the size and the winning number. So the player has to key in the winning number because he bought this thing. There's a winning number. All right. So you have winning ticket or you did not. And this time we did sorry. This is a linear search. So I need to let me see. I want it to be a what? Binary search. Is that right? So I need to see if this one is wrong. Then hold on. Let me remove it. And let me take number 3. Is that okay? Then I'll give you the 1, 2 once I finish. All right. So here I have a search here and I'll give to you right away. After I explain it, I'll give you right away. So we do this. We do exactly the same thing. Bound equal false. First equal 0. Last equal middle. The element minus 1 with middle. This is exactly the same thing. Well, not found. And first, last, and last, you calculate your middle. And if middle is the value, you got it. Otherwise, we either switch our last or switch our first. Okay. So I am going to do this one with you. Then all right. So let me run it right now. So I build it. And I start without debugging. All right. So enter lottery number here. Let me put this. That's 5 number, right? So I'm going to put 66666. Okay. And so you did not win this. All right. So if I run it again, and I started, and I'm do 7777. Okay, 7. All right. So you have a winning ticket. So because the computer this day, your process is very slow, very fast already. So you really don't see the the too much different. But if this is online, it will make a huge difference. If you use binary search, you'll be allowed your user right away, instantly get your feedback. All right. So once again, this part need to memorize. The algorithm need to memorize. And I hope you like this program.